Hello everyone, I am Professor Anish Vora and I welcome you all in this video lecture. In this video lecture, we will study about half wave rectifier. We know that a rectifier is a device with the help of which we can convert AC supply into DC supply. Now, let us understand what exactly we mean by half wave rectifier. In half wave rectifier, conduction of current take place only during the positive or negative half cycle. So conduction through the load is possible only in the half cycle of the input alternating supply. Now let us see the circuit diagram for the half wave rectifier. We have transformer. We use one transformer. On the primary side of the transformer, we give 230 volt single phase AC supply. On the secondary side of the transformer, we get step up or step down voltage as per our requirement of the DC voltage. On the secondary side, we connect one diode, and after a diode, a load is connected. We have diode D, anode and cathode of the diode, and in the series with the diode, load resistance is connected, and we have positive and negative terminal across the load resistance. So this is circuit diagram for the half wave rectifier. We have used only one diode. Now let us see the waveform of the half wave rectifier. We have input cycle, and we know that input side we have alternating supply, so voltage is applied. On the x-axis we have taken angular frequency, that is omega t. On the y-axis we have taken magnitude of the voltage. So we will see the waveform of the input voltage. We have positive half cycle as well as a negative half cycle. And we have 0, pi, 2 pi, 3 pi, 4 pi, 5 pi, that is our angular frequency. So this is our input AC positive as well as negative half cycles. Now conduction through the diode is possible only during the positive half cycle. So now let us check the waveform for the output. Again, we have taken angular frequency on the x-axis, and current DC current through the load is taken as an output to waveform. During the positive half cycle, conduction takes place and current through the load passes in a unidirection. During negative half cycle, there is no conduction at all. Again, during positive half cycle, conduction takes place. So, the current through the load at the output side, it is a unidirectional, and that is why we can say that at the output we are getting DC current. Function of the transformer. We use one transformer in half wave rectifier, and the function of the transformer is voltage can be step up or step down with the help of transformer to get certain DC voltage from rectifier. So depends upon our requirement of the DC voltage, we have to either step up or step down the input 230 single phase AC voltage as per our requirement, and this can be done with the help of transformer. One more function of the transformer is that circuit is isolated from the supply mains. So our electronic circuit or the DC side, that is isolated from the power mains. Now let us understand the working of the half wave rectifier. Here we have secondary of the transformer, point A as well as point B. We have anode of the diode, we have cathode of the diode, we have a load connected in series with the diode, we have positive terminal, we have negative terminal, and across the load we have terminal X and Y. So during positive half cycle, point A is positive compared to point B. Anode is connected to point A. So during positive half cycle, anode is more positive compared to cathode, and diode D is in forward biased. So during positive half cycle, PN junction diode offer a very low resistance to the input supply, and the voltage applied to the diode, the junction allows to pass the current through the diode and to the load. Let us see. So point A is more positive, diode is forward bias. So from point A to anode and cathode, current pass. Then through the load from point X to point Y, and then return to point B, and again from B to A, and the circuit or the current completes. The path of conduction, that is from point A to anode to cathode, then to X, then to Y, then to B, and then at the last again back to A. So this is our path of conduction during positive half cycle, and during positive half cycle the same cycle appears across the load in single direction. So the flow of current through the load is from X to Y. So X terminal is known as a positive terminal, and Y, that is known as a negative terminal. During negative half cycle, point A is negative compared to point B, and diode is reversed biased. Anode is connected to point A, and that is more negative compared to point B. So during reverse bias condition, diode D will not allow current to pass through anode to cathode. So during negative half cycle, there will not be any voltage or current across the load. So that is why during positive half cycle only conduction take place across the load, and during negative half cycle there is no conduction at all, and that is why it is known as a half wave rectifier. We have certain disadvantages of the half wave rectifier. Output voltage is pulsating DC. We have seen the waveform. It is not a constant DC, but we are getting pulsating DC at the output waveform. Power is delivered only during the half cycle, so the output power is very less. If we calculate the average power, the power at the output side is comparatively very less. Output voltage is half that of the full wave rectifier. In case of full wave rectifier, during positive as well as during negative half cycle, conduction take place. So in half wave rectifier, the output voltage is half that of the full wave rectifier. Current flows only during the half cycle, so chopped input filter cannot be used. So this is all about half wave rectifier. Thank you for watching my video. Keep watching. Thank you very much.